All right, this is section 5.3. We're talking about graphs of polynomial functions. Okay, so let's look at the characteristics of these types of graphs. So a polynomial function is going to be of degree 2 or more, and it's going to have graphs that doesn't have any sharp corners. We call those smooth graphs. And they're also not going to have any breaks. We call that continuous. So polynomials will not have any sharp corners, and it won't have any breaks. So we call it smooth and continuous functions. So like this one right here, we have a smooth, no sharp corners, and a continuous function. So this one is a polynomial. Whereas this one right here, it is smooth, but it is not continuous. So this is not a polynomial. So let's see which one of these are polynomial functions. So this first one here, it is smooth. So it has no breaks and it's continuous. There's no sharp corners, and that was backwards. There's no sharp corners, there's no breaks. So this one is a polynomial. Now this one does have a sharp corner right there, so this one's not a polynomial. So here is smooth and continuous, that's a polynomial. This one is smooth, but it is not continuous, so it is not a polynomial. Now, do all polynomial functions have as their domain all real numbers? Yeah. So that means the domain of any polynomial, it goes from negative infinity to positive infinity. If we look at this one right here, so this polynomial keeps going down this direction, keeps going up this direction. And as it's going down, it increases in the negative x values. That just keeps on going forever. As the function is going up, it keeps increasing in the positive x direction. So it keeps on increasing for the positive x. So it goes out to negative infinity and to positive infinity. So the domain would be from negative infinity to positive infinity for polynomial functions. Now let's find zeros for polynomial functions by factoring. So what we're going to do is the same thing as what we did for finding y and x intercepts, except for now we're just going to add factoring to it. So let's look at this one right here. R of u is equal to u raised to 6 minus 3u raised to 4 plus 2 u squared. And we're going to give the coordinates for the r-intercept and the u-intercept. So the r-intercept is basically like the y-intercept, and the u-intercept is basically like the x-intercept. So when we're finding the r-intercept, we're saying that we're going to set u equal to 0. When we're finding the u-intercept, is what we're saying is we're setting r equal to 0. So for the u-intercept, r is going to be equal to 0. So 0 is equal to u raised to 6 minus 3u raised to 4 plus 2u squared. And I'm going to factor out a u squared. So u raised to 4 minus 3u squared plus 2. Okay, now I'm going to go ahead and factor out inside here. Actually, let me change it first. This will be u squared, whole thing squared, minus 3u squared plus 2. Okay, so we got u squared, be u squared, minus 1 minus 2. So negative 1 times negative 2 gives me a positive 2. Negative 1 plus negative 2 gives me negative 3, so that checks out. Now, by the zero product property, I'm going to set all these equal to 0 and then solve for u. So u squared equals 0, u squared minus 1 equals 0, and u squared minus 2 equals 0. So we're going to square root, and remember, when you put the square root, you also put plus or minus. But since this one is 0, 0 is neutral, so it doesn't have a plus or minus before it, so it's just 0. Going to move 1 over. I'll go ahead and move 2 over. Whoops. And then square root. Put my plus or minus sign in front of that. Square root of 1 is just 1. Square root of 2 is square root of 2. Okay, so now I'm going to put each one of these in 2 coordinates. So for this first one, this would be 0, 0. For these right here, it would be 1, 0, negative 1, 0. For here, this would be square root of 2, 0, negative square root of 2, 0. Okay, so all of these right here, this would be my u-intercept. Now let's go back and find our r-intercept. Okay, now r-intercept, that means that u is equal to 0. So r of 0 is 0 raised to 6 minus 3, 0 raised to 4, plus 2, 0 raised to 2. This term goes to 0. This term goes to 0. This term goes to 0. So r of 0 is equal to 0. Now if we put that in coordinates, this would be 0, comma, 0. So this would be our r-intercepts. Okay, let's look at this one. Given the function p of t is equal to t raised to 3 minus 5 t squared minus t plus 5, we're going to give the coordinates for the p-intercept and the t-intercept. Okay, so for the p-intercepts, that's t is equal to 0. For the t-intercepts, that's p is equal to 0. So let's look at the t-intercept. So p is equal to 0. So 0 is equal to t cubed minus 5t squared minus t plus 5. And what I'm going to do is I see 4 terms, so I'm going to try a factor by grouping. So I'm going to group these two together, and then I will group these two together. Oops. Let's keep that negative in there with it. Okay, so I'm going to factor out t squared. So I'm left with t minus 5 plus, and actually what I'm going to do is notice I've got t minus 5 here and negative t plus 5 there. So the signs are opposite, but I still have a t and a 5. So what I'm going to factor out is a negative 1 from here, which will change the signs. Okay, so now both of them have this t minus 5. So that's what I'm going to factor out. And I'm left with t squared minus 1. Okay, I'm going to set both of these equal to 0 and solve for t. So t equals 5. T squared equals 1. Square root plus a plus or minus. We'll come over here. So t is equal to plus or minus 1. So the coordinates for the t-intercept should be 5, 0, 1, 0, and negative 1, 0. Okay, now let's go back and find the p-intercepts. Okay, so the p-intercepts is the same thing as saying t is equal to 0. So p of 0 is 0 cubed minus 5 times 0 squared minus 0 plus 5. This term will go to 0. This term will go to 0. This term is 0. So it looks like p of 0 is equal to 5. Okay, so the coordinates here will be 0, comma, 5. So that would be our p-intercepts there. Okay, let's look at this one right here. G of m is equal to m minus 2, that's squared, times 2m plus 3. Okay, when we're looking for g-intercepts, that means m is going to be equal to 0. When we're looking for m-intercepts, that means that g is going to be equal to 0. So if we look at the m-intercepts, that's going to be g is equal to 0. So 0 is equal to m minus 2 squared times 2m plus 3. They're already factored, so I'm going to separate them out and set them equal to 0. Okay, so I'm going to square root both sides, so m minus 2 equals 0. So m equals 2. Subtract 3 from both sides over here. Divide by 2, so m is equal to negative 3 halves. So it looks like the coordinates for this one would be 2, comma 0 and negative 3 halves, comma 0 for our m-intercepts. Okay, now we're going to go back and look for the g-intercepts. Okay, so g-intercept, that means that m is going to be equal to 0. So g of 0 is equal to 0 minus 2 squared times 2 times 0 plus 3. Okay, so that would be negative 2 squared. This would be times 3. Negative 2 times negative 2 is 4 times 3. That is 12. Okay, so the g-intercept is going to be 0, 0, comma 12. And that's it. Now let's talk about zeros and their multiplicities. So graphs behave differently at various x-intercepts. And remember, x-intercept is where the graph crosses over the x-axis. Okay, so that's an x-intercept. I have 2 right there in that function. Sometimes the graph will cross over the horizontal axis at the intercept like it does here and here. Other times it will touch it and then bounce off of the horizontal axis or the x-axis like it does right there. So for zeros with even multiplicities, this is the important part, the graphs touch or are tangent. Tangent means just getting really close to it, to the x-axis. Okay, so they touch and they bounce off. That's even multiplicities. For zeros with odd multiplicities, the graph will cross or intersect the x-axis. So it looks like for this root here, or 0, or x-intercept, that they all mean the same thing. Looks like that one has an even multiplicity, whereas these two right here have an odd multiplicity. So looking at this one right here, this graph right here. Now notice I've got 1, 2, 3 different x-intercepts, or zeros, or roots, whatever you want to call them. These two right here, they cross over the x-axis, so they look like they have odd multiplicities. This one right here touches and bounces off, so this looks like an even multiplicity. Now let's look at where these roots are occurring. So at this point right here, this one looks like it is negative 3. So the x-intercept is negative 3, so x equals negative 3. This one right here, x is equal to negative 1. And right here, x is equal to 2. Okay, now look at this function right here. We have x plus 3, x minus 2 squared, and x plus 1 cubed. All right, now if I set this equal to 0, because that would be finding x-intercepts or roots of this, so 0 is equal to x plus 3, x minus 2 squared, x plus 1 cubed. So set each one of these equal to 0. So this one would be negative 3. Hey, that's our first one right here. We're going to square root both sides, so x minus 2 equals 0, x equals 2. Hey, there's this intercept. We're going to cube root both sides, so x plus 1 equals 0, x equals negative 1. Hey, there's our last one right there. Okay, so within this function right here, we have found all of our x-intercepts. Now notice this is negative 3, but inside here it was positive 3. This was negative 1. Inside here it's positive 1. This was positive 2. Inside here it's negative 2. Okay, just keep that in mind when we're solving for these later. Now notice the multiplicities are what these are raised to. Okay, so let me change this to f of x. This is raised to 1. This is raised to 2. This is raised to 3. Those are the multiplicities. Now look at, let me get rid of some of this right here. We'll say x is negative 3, x is negative 1, and x is 2. Look at the odd ones, 1 and 3. So for x equals negative 3 here, raised to 1, hey, it's odd, it goes straight through. X plus 1, that's x equals negative 1. That's odd.